Okay, let's do some multi-step mole conversion problems. Now, sometimes you're not starting out with moles and going directly to grams or to atoms. Sometimes you want to go, for instance, let's say atoms to grams or grams to atoms. So let's do that. It'll take more than one conversion factor. Let's say you have 3.4 grams of, let's use, how about iron? And we want to find out how many atoms, number of atoms. So again, you just use the steps of dimensional analysis like we always have, and it should be straightforward. So write what's given, which will be a number, a unit, a formula, since we're doing chemistry, times fraction bar to set up your unit conversion, bring down grams and bring down your chemical formula. And then going from grams to atoms, again, we can't do that easily. But what we can do easily is go from grams to moles. So this is the only step that takes a little bit of thought. And then once you're here, you just reset and you just do these other steps automatically. And now back to thinking, well, hey, now we can go to moles to atoms, no problem. So that's a multi-step problem. Can you remember how to write in all the numbers at this point? We know we're done because we're going to end up with the unit that we want, atoms of iron. Because these will cancel. Moles iron over moles iron is going to cancel out. Grams iron over grams iron is going to cancel out. So what type of conversion factor is this? What are we doing here? That's molar mass. So you simply take a look at your periodic table. You find iron, and you'll notice it's element number 26. So a mole of iron has a mass of 55.85 grams. 1 mole of iron has a mass of 55.85 grams. And we know Avogadro's number, so this one's easy. So 1 mole of iron is 6.02 times 10 to the 23 atoms of iron. Get your calculator out and plug in the numbers carefully. 3.4 divided by 55.85, enter, times 6.02, second function double E, 23, enter. Okay, so 3.4 grams of iron is equivalent to let's see, two significant figures, 3.7 times 10 to the 22nd power atoms of iron. That's a lot of atoms in 3.4 grams of iron. So this is an example of a multi-step conversion where you need more than one conversion factor. Now, I don't recommend stopping. Sometimes students like to say, well, you know what, I'll just do this one, and then I'll do an equal sign, and then I'll take my answer here, and then I'll come down here, I'll do another problem, and then I'll hit an equal sign, and then I'll do another problem, and then I'll hit an equal sign. I would rather you just do one long line of conversion factors until you get to the answer. That's the better way to do it. Let's do one more. Let's do one involving volume. Let's say if you have 4.2 liters of carbon dioxide gas, how many, why don't we do atoms? How many atoms is in not atoms, molecules. How many molecules? How many molecules is in 4.2 liters carbon dioxide gas? How many molecules of carbon dioxide would occupy 4.2 liters of carbon dioxide gas at standard temperature and pressure? That just means we use the molar volume of a gas, which is 22.4 liters per mole of gas. All right, so let's get started. What do we write first? Right, the given. Times fraction bar. Bring down the unit and formula. Now it's getting easy for you. We can go from liters to moles. That's the molar volume of a gas relationship. We're not done. We need to get to molecules. So what do we need to do? Do another times fraction bar. Bring down moles of CO2. And we think a little bit. Can we go from moles to molecules? Yes, we can. How many molecules is in 1 mole? Oops, CO2. That's right. There's 6.02 times 10 to the 23rd molecules in 1 mole of CO2. Now, how many liters of what volume of CO2 would represent 1 mole of CO2? We know that the molar volume of a gas, 22.4 liters of CO2 is 1 mole of CO2. And now again, we're done with our numbers, we're done with everything. We're just going to plug this in to our calculator. 4.2 divided by 22.4 equals times 6.02 second function double E, which is times 10 to the 23rd power. Enter. We're going to have two significant figures because the term with the least amount of numbers is 2. That's 4.2. So our answer is going to be 1.1 times 10 to the 23rd power. 1.1 times 10 to the 23rd molecules of CO2. Here's what's interesting. I forgot what we were trying to figure out, but then I realized I was done. So when this cancels out, you know what your final unit and formula is going to be because it's going to be the last thing in your problem. Okay, let's do one more. I'll try to make this one pretty challenging. And then I think you have a good idea. Let's say how many carbon atoms are in, let's do 4.95 kilograms of carbon dioxide. Okay, so a little bit different. I'm trying to just make up a problem where I've got different units. We're not using grams, we're using kilograms. I'm talking about atoms in this molecule, so there's some different things going on here. So how do we start this problem? Same way we start all the problems in dimensional analysis here. Write the given, 4.95 kilograms CO2 times fraction bar, and then bring down kilograms of CO2. So this is automatic. Now I got to think, can I go from kilograms to carbon atoms? Of course not. Not in any easy way. Can I go from kilograms to moles? No. I can go from grams to moles, but here I have kilograms to moles, so I have to go to kilograms. So what would be the next obvious step? Get to grams. That's the next step in our path. And we know we can do that. And then this is automatic, this part. Okay. Now let's think a little bit. Well, this should be obvious now. We're going to go from grams to moles. Now, here's an interesting thing. You know what? I should have changed this to oxygen to make it a little more difficult. Would you allow me to do that? How many oxygen atoms? Oxygen. How many oxygen atoms are in 4.95 kilograms of CO2? Here's why I want to do that. Because watch, when I bring down moles of CO2, it would be really easy to go to moles of carbon, because 1 mole of CO2 has how many moles of carbon? 1. So this makes it just a little more challenging. You'll see why in a second. And then moles of oxygen to atoms of oxygen. We can do this. All right, so let's fill in these numbers. Let's start here. 1 kilogram is 1,000 grams. If you look at the molar mass of this, you know that 1 mole of CO2 is 44 grams of CO2. We know that in 1 mole of CO2 you have 2 moles of oxygen atoms. That's why I wanted to do that, because it just changes the numbers up here. If it was carbon, then we would have just done 1 mole of carbon. And then we know 1 mole of oxygen is 6.02 times 10 to the 23rd atoms of oxygen. Let's go ahead and punch in our numbers real quick. And let's see here. 4.95 times 1,000 divided by 44 times 2 times 6.02 second function double E 23. And the answer that we get, and we're going to want to have 2 significant figures, is going to be 1.4 times 10 to the 26. So that equals 1.4 times 10 to the 26. Do you know what the unit's going to be? Right, what we're left with here. Atoms of oxygen. I hope that was helpful. Do your practice problems and learn multi-step conversions using moles. Have a great day.